Hello, so today I'm going to show you this V40 motherboard on an ISA card. So if you're not familiar with the V40 processor, it's it's got a V20 in the core, and if you know about the V20, it's based off the 8088. It's was built by NEC to it's a faster. It actually runs like the opcodes faster than an 8088 would at the same clock speed. So the reason why it's a V40 though is all the peripherals are built in. So if you've seen my other video for the V20/8088 motherboard, you can see there's a lot fewer chips on this. And actually, I'll just show you the chips we added, then I'll talk about the processor. You still have to decode the address and data lines. So you've got your data transceiver and then your address latch for the 0 through 7 and then 16 through 19. 8 through 15 you don't have to latch, just like the V20 and the 8088. And then we've got our memory here on these three chips. ROM 32K, the very top end that starts at F8000. And then just below that's another 32K that starts at F0000. And I use this RAM in conjunction with my ROM. Then we got our 512K at the very bottom, address 0. And this is like your programming space. Obviously, your interrupt vector table is going to be at the very bottom. And then I've got a 8255. This one's a 71055. It's just the NEC version. This is for the keyboard. This is on port 60. And then decoding up here, so memory decoding, and then all this I/O decoding just for the one chip. The ports up here. I'm still working on a keyboard. I really like to go with a USB keyboard, but I'm looking at using the like an 8042 or one similar. But if I can get a USB keyboard to work, then I'll definitely go that route. Power, it's powered from the board. You kind of could power it from the socket. You'd have to maybe solder some jumper wires. The big thing is the power OK pin, the very top one here. It's connected in with the reset. So it doesn't go high until the power's stable. And then that makes it so that when you turn your switch on, you don't have to hit the reset button. So definitely designed it powered from the board, not from the back plane you have it plugged in. Then over here, we do have a clock, the 8284, and a clock divider, 74 LS74. Now, if you notice, there's two crystals. The V40 does have its own internal clock, and then what this one is for your peripherals. So, like I have a V40 that I want to try. This one runs at 8 megahertz, -8. I have a one that runs at 20 megahertz. I'm really excited to try that one out. So it would require a 40 megahertz crystal here. This one's 16. And with that being the case, that's going to mess up your clock speed, like on your speaker and your timer. So this one's designated, it's kind of blurry, 14.31818. And then that divides down properly to the proper for your speaker and your system timer. So the processor itself has built in the direct memory access controller. It's got an interrupt controller. The interrupt controller is identical to the 8259. You program it just the same. It's got a system timer, the 825453. It's identical to that. And then it does have a serial port. I don't really plan to use the serial port, like not right now anyway. It's multiplexed with the DMA controller pins. It doesn't work with the DMA controller. It just, on the ISA card slot, it's hooked up to the DRQ3 is the receive, and the transmit is like the DAC3. I might have that backwards, but so that would interfere with your usage of the direct memory access if you were using it. But you know, a lot of people, I don't even know if you'd use the direct memory access on a project board, only if like you're going to use like ISA cards that require it. Now, the DMA controller is not compatible with the 8237 or the 57. It's kind of its own thing. So the 8237 is 16-bit, and you have a index register at port 80, like 1, 2, and 3, that sets the upper address lines. Well, this one is 20-bit right off the bat. So it's programmed a little differently. It functions the same, but it programs differently. But I did include this little pin here. This is part of the serial system. I threw that on there. It's like a ready to receive pin, so that if somebody wanted to play at the serial port, you'd have all the pins. And you can see that I did put a ZIF slot on for the ROM, so you don't have to sit and pry it in and out. Works pretty good. The only thing that's not connected on the ISA card slot is the address enable that would come off the 8237 direct memory access controller. The V40 just does not have a pin for that. Now what I'm going to do though, I thought about this since I built this one. I'm going to put a logic circuit here that takes all the DAC lines, the DAC 0 through DAC 3, and if any of them goes low, it'll raise the AEN pin. And I don't even know how many ISA cards require that, but I want it to be as functional as possible. So speakers up here, the 33 ohm resistor. As you can see, there are a few other resistors on here. These are just like pull up, pull down resistors for various things. Some of them may not even be needed, but I just kind of put them on there. So I'll show you to operate here. Pause it. Okay, so I've got on the breadboard here. I'm using my breadboard adapter. Pretty soon here I'm going to build my own backplane. And then I'm going to take and make an adapter that plugs into the card slot on a backplane and comes off with header pins so that you can still prototype on a breadboard. Something else I need to mention is, so even though these are internal with the peripherals, you have to set them up. So in the code, one of the first things you have to do is assign the address location of the peripherals and like select which interrupt pin like the serial port would use, and you can set the timer to use our external clock or an internal clock. So that's something that's really hard to find documentation on. I found one PDF file that documented it, but it actually was about another motherboard, but it that used the V40. So it's very helpful, and I'll try to include that on my website. So let me show you it run. Get the speaker going.